Hi, a very good day to everyone. My name is Lem. I'm a lecturer from the Faculty of Science, University Tunku Abdul Rahman, UTAR campus. I've been teaching mathematics for years. Here, I'm going to give you a brief demo on a software called Geogebra. The software is quite good for dynamic mathematics teaching. And this video is one of the numerous activities in conjunction to the KLESF 2020, stand for Kuala Lumpur Engineering Science Fair. The fair is supposed to run in the first weekend of December. However, due to the COVID-19 pandemic, it is conducted virtually and now called the KLESF. If you are interested, you may visit the website of the KLESF, or you can Google KLESF for more information. This is the poster for the KLESF, and you can see here UTAR is one of the joint organizers in this event. In this short video, I'll try to introduce to you briefly what Geogebra is. I'll present some demo on what Geogebra can do, what it is good for. Meanwhile, you may try to imagine how you can use Geogebra in your classroom for teaching in the future. Of course, this is not a training course nor a self-study tutorial video on Geogebra. It is going to be just a quick browse through of Geogebra, and my target audience are school teachers, in particular school teachers who are teaching mathematics. Okay, let's get started. Geogebra is a free open source software for dynamic mathematics. Started in 2006. It's about 15 years old. Its name is actually a combination of geometry and algebra. Therefore, Geogebra. You may download the Geogebra freely from the website www.geogebra.org and install in your own machine. If you don't feel like download and install from the same website, you can actually use the online version, which run on web browser such as Firefox and Google Chrome. So this is the website, official website of Geogebra. If you want to download, you can point to this apps download. Once you click this, you will see Geogebra Classic 6 and Geogebra Classic 5. This is a newer version, this is the older version. If you want to download into your machine, you may click on the download, or if you want to use the online version, you may just click the start, and depend on how fast of your internet line and how fast is the machine. If you just run online in the web browser, for more stable, if your line is not fast, then it's good to download it and install it into your machine. You may use the classical version 6 or the classical 5. Of course, in this video I'm using the version 6 for the recording. Let's have a look at the description from the Wikipedia. So in the Wikipedia, Geogebra is an interactive geometry and algebra, statistics and calculus application intended for learning and teaching mathematics and science for primary school and also up to university level. It's available in multiple platforms, can be in Windows, Linux, Mac, and even your iPhone and your Android handphone. You may try to download some of these in your handphone and try it out when you're free. Okay, when you first open the Geogebra, this is the default interface that you see. This is the input bar for you to input some formula to do calculation for some graph, and this is the graphic view, 2D graphic view working window here for to do drawing or plot graph. And of course, you have the toolbar here, full list of toolbar here for to choose from. We have the undo and redo button and the internet search button for to search some of the things. A menu pull down button, and of course this is a zoom in and zoom out and the full screen toggle. And we have two more style bar here. This is the style bar for the algebra window, and this is the style bar for the 2D graph here. Okay, this is the interface by default. Okay, now we'll learn how to use a Geogebra calculator. Now you can make this window smaller and make the algebra window bigger, and you can start to key in some calculations here. It will behave as a calculator. Let's try the pi. Just key in pi and enter. It will give you 3.14 by default. It is 2 decimal places, and it will assign to a variable a. And if you want to have a higher decimal place, you can go to this menu bar here. Inside the sub menu, you can find the setting, and in the global setting here, you see the default is 2 decimal places. You can change to, let's say, 4 decimal places. If you think this is good, you can save the setting. If you don't like it, you may restore the default setting, and you even can change the font size and some other things here. Well, let's satisfied with the 4 decimal places, and we close the menu and go back to have more calculation here. You may try some trigonometric function that says sine. Just key in sine, and you can see before you finish there will be a pop-up help file to guide you through all the relevant functions or built-in command starting with sin. Okay, so you just want the, of course you can select it or by continue typing. When you start the open bracket, it will automatically give you the close bracket. Let's say we calculate sine 30. Press enter. So by default it is going to be 30 degree, so we know sine 30 degree is going to be 0.5. And how about if you want it to be sine in radian, then it is sine 30, then you put RAD there, stand for radian. This time you will have 0.5, but you have negative 0.988. In fact, you can change the unit from default unit degree to radian. So if you want to do that, you may go to this menu again, have the pull down menu, go to the setting, and click on this stand for the algebra window, and you can see the default unit is degree. You may want to change to radian, okay? Or you may change to degree units second division. So let me keep it as degree. Okay? So in this case, if you want to be, let's say you are in the radian mode, if you want to be very specific to be in degree, you can just key in a sine 60 degree by putting a DEG there, stand for degree. IAD stand for radian, DEG stand for degree. It will work. Of course, to have a checking, you may try sine pi radian. Of course, we know sine pi radian is 0. Okay, let's verify. And let's try some simple calculation. Let's, for example, 708. Just like a calculator, and then you press enter. You get this. So by default, it's giving you analytical calculation. If you want a decimal place calculation, you can click on this approximate calculations, then you get the approximate calculation. If you want back to analytic, you press this arrow again. You give a service the switching between the analytic and the approximation calculation. And let's try some others. For example, ln ln. Let's say 9. Get the ln 9. How about exponential? Just need the exp. Same for exponential. 999. Oh, it's too large, right? So exp 9. Of course, the exp1 is 2 for 783. They have a power and square root. Let's say 4 square. You just press the head 6 there. So what you should key in the keyboard is 4 head 2. The head is just shift 6 to get this thing out. Just stand for the 4 to the power 2. Okay? And let's try square root. Of course, you may power half, or you just type in the command sqrt. We know if you want, it's going to give us 9. So you know how to use Geogebra as a giant calculator for calculations. And we'll see some other features later. Of course, if you want to delete some of the calculations, you can just click on this 3 bullet point here and you delete. Of course, if you want to delete more than one, you click on this, and by pressing your shift key, you can select more than one. After it's selected, you can just press your delete key in your keyboard. It will delete more than one. If you don't press the delete key, you can right click here and delete. Okay. So let's delete all this and start and another section. Okay, now let's see how to use Geogebra using the 2D geometric window to do some 2-dimensional geometrical drawing. Let's get started. So in this case, you need to use the menu in this menu bar. Of course, when you click on the menu, there are quite a number of sub menu there. Let's start by learning how to make a point, draw a point. By clicking on the point, just simply pick a point here and pick another point here. You can see by default the coordinate of the point is given to you, and if you point your mouse here, you can scroll your mouse up and down to zoom in and zoom out. And if you click on this and drag, of course you are still in the point mode, so any time you click on this, it will give you a point. Let me go back to the cursor and select the move, and now when you click on the empty space here and you drag, it will actually move around the graph paper. If some of the accident the point you don't want it, then you click on this, right click and delete. Okay, now let's try to draw a line. You go to this menu and select the line or the line segment. In fact, you have a help here tell you what to do to use this menu. To get a line segment, you need to click on the 2 points. Then a line segment is more than 3. Draw for you, and you go back to the cursor. In fact, you can move around point A or point B. Your line will just follow accordingly, and all the coordinates will change accordingly. Okay, now let's add another point here, point C, and we learned how to draw a parallel line. So when you hover your mouse here, you can see the help file, some help message here. So in this case, you select a point and a parallel line. So you select point C. Sorry, I think let's see how to draw a parallel line. You select this select the parallel line. In fact, when you are in this menu, you have a pull down menu, and depend on what you select, there is always a help message here, guide you through what to do. So now we want to get a parallel line. So what you need to do is to select one of the point and then the line to get a parallel line. Select the point C and this line, that will straight away give you the parallel line. In fact, you can move around the point C and even the point A and point B, the line is still parallel all the time. Actually, you can move around if you want to see the more formula or more graph and drag it further. Okay, let's see how to change some of the setting or the style. You click on the line and you can see some setting here. You can change the color and even change the style, make it thicker, increase the number, make it into dotted line, and so on. And for the label, you can move around the label, the point label, you can move around. And in fact, besides selecting this menu, if you know the command, you can create the object by using the command. For example, if you want to create a point with the coordinate 2, 0, let's say, you just start the bracket 2, 0. That is the command to create a point. Press enter. Then you see a point here in 2, 0, which is on the x-axis. Okay, this one way to create a point. And now let's see how to create a polygon. Click here, select polygon by selecting all the points. You just select all the points for your polygon and go back to the starting point and you get the polygon. Of course, a lot of labeling here. If you don't want to see them, you can hide them. Can you see? There's a bullet point here. On and off the light, you hide some of those elements there. It's just hiding, but it's still there. In fact, besides hiding, you can even delete them. So if you don't want this, you can click on this and delete it. Okay. Now let's move this point here and move this point here. We try to create a regular polygon. So what you need is select 2 points and enter the number of vertices to get the polygon. Let's try it. We select this point C and point D, and there's a menu here asking for how many vertices or line for the polygon. Let's say I want a polygon with 9 vertices and press OK. It will give me a regular polygon with 9 vertices like this. Of course, if you want, you can change the color. Okay. Control the transparency, whether you want transparent, less transparent. Okay. So after finish, if you think this is too messy and you want to have a clean file again, you can go to this and select the new and don't save. Of course, if you want to save, you key in the file name, it will save for you. So we want to have a clean file again for another drawing. So we click on this new and don't save. Okay, now let's see how to do some drawing involving circle. You can select the circle. Let's try this circle with center and radius. You need a center point and some radius. Click it and you just simply make a center here, and then a pop-up window asks for the radius. Let's say we say 4, the radius is 4, and then you enter or OK. You straight away get the circle center at A with radius 4. Now let's draw an arc of the circle. arc, circular arc. In this case, you need center and 2 points. Click the center and 2 points. 1 point here, 1 point here, let's say, and you get the arc. But it seems visible because the color is the same. Therefore, we should change the color a bit, and the arc is labeled as D. Let's click on this, select it, and change the color here. Let's change the red color. Okay, so you can see the arc there. How about we measure the angle? But before that, it's good to have a segment to recognize where is our angle. From A to B, from A to C. Let's measure the angle BAC, and there's a tool for you to do that also. Go to this angle to measure angle. Select the 3 points. Select this. Go to A and go to C. So you can see the angle by default is in degree, and I set to 4 decimal place. Let's move it around. It's labeled as alpha. If you don't like the term alpha, you may click on it, right click, and rename. Right, you can rename the from alpha to something else. Let's stick to alpha. And if you want, you can also change the appearance of the angle. Is now green color. If you want, you can change it to, let's say, orange color, and make this thing a bit less transparent, and so on. You can experiment yourself. Let's add some text. Learn how to add text. You go to this. There's a text menu there. Tool there. You click to a point where you want the text to appear. Okay, then you just key the text in this pop-up window. So let me key circle and arc and angle, and you click OK. Then the text appear here. Of course, if you want to move it around, you point to this arrow and move it around. Of course, you can change the appearance or color of the text by changing this. Let's say you want this to be bold face. One more way to change is to click on the text, right click, and then click on the setting. Then you can do the coloring, positions, a lot of setting you can do. For example, I want to make it to become a large text, and the color. So there are 2 colors. One is the foreground color. One is the background color. Let me change the background color to white, and then the foreground color to red. Okay. You still can move it around. Okay, after, let's say you have done a little bit of fancy drawing and you want to save the drawing. So let's learn how to do this. Export image. After you have some drawing here, you go to this hold down menu. There is a choice export image. Click on this. Either you copy this to the clipboard. After you copy on the clipboard, you can paste on, let's say, Microsoft Word or PowerPoint or some other photo editing software. Or if you want the whole graphic to be downloaded, save as a file. By default it's PNG file. You can click on the download. Then if you save as a PNG file, like you can see here, and you put on a place where you want it to be, and you can change the name. But I don't want to save it, so cancel. If you want the whole project, including all this formula and the coordinate of the circle, to save as a whole Geogebra worksheet of the project, then you can click on this, and you can click on the save. So you can change the name. By default it will be .ggb. Then click save. You ask for location where you want to save, and as a .ggb. So you either save the image as a PNG file, or you save the whole project as a GGB file. Okay. I'm sure many of us is going to teach translation, reflection concept somewhere in our syllabus. This can be done also using Geogebra. Let's see how. I have a polygon here and a line here. I want to show you translation, reflection about this line. In Geogebra, you click on this, select the reflect about line, click on the object you want to reflect and click on the line. Then you get the image. If you cannot see, you may need to drag further down or maybe zoom smaller or bigger to see. And this is active. You may rotate and change the line and see the effect. If you don't want the graph paper, then you may select this blank. You don't have the graph paper. If you don't need the XY axis, you may also select this. If you want it back, you select it again, and if you want back the graph paper, you select it again to get back the graph paper. And of course, if you teach translation like this, may make the student feel boring. Why not we make we teach them using not a polygon but a more interesting graphic or cartoon that will attract the attention more. Let's see how. To do this, we first learn how to import some graphics inside Geogebra. I assume you already have some graphic or cartoon or some beautiful, interesting image saved somewhere on your desktop as a JPG or PNG file. You go to this. There is an image for you to import image and file to choose from. Of course, I have some file here. I choose to carry. Open and OK. And you see the file is already imported here as a graphic, and you can rotate it about a bit and make a zooming, or even change the location like this. Now let us teach the students about the translation rotations by working on this graphic instead of a polygon. Now we create a line first. You need a line which joining 2 points. You may want to make this line to a dotted line. And control the thickness. Okay. Now let's do that thing again. Reflection about a line. You click on the Kelvin and click on the line. You get a reflected image there. And if you want, you can move the line about just to see the effect of the reflection about different line. Okay. Maybe there's a better way to make the student more interesting when you're teaching reflection, rotation, and translation. Okay, now let us do a rotation. Go to this, rotate about point. You click on the picture and the rotation point. Sorry, maybe something wrong. Rotate about a point and ask for the angle. By default is 45 angle. Of course, you can change the angle by tapping in either counterclockwise or clockwise. Okay. Then you have a reflected image about this point, 45 degree. But it seems not easy to understand, right? Maybe it's better to have the angle increase or decrease in a slider bar. That will make the explanation more interesting. Now let us delete this and let's do that again. So in order to do that, you need to create a slider bar. You need to go to this and click on the slider and ask for the slider location where you want to slider to locate. I just simply put here, and whether you want this to be a number, angle, or integer. In this case, of course, we want it to be angle because we want to change the angle. So it defaults 0 to 360 degree. The increment is 1. Then you click OK. You have a slider bar. but the default angle is alpha. Maybe it's not easy to key in the alpha later when you want to refer to it. Now let us right click and rename it from alpha to something easier. Let's say A. Okay, now you have the angle changed to A. Now you go to this reflection about a point. Maybe before this you need to create a point of rotation. Let's say this is my point. So now come back to this, rotate around point. You need the figure and that point and the angle. Now you don't specify the angle, but you refer the angle to the slider, which is A. You know, the A. And let's say you want to select counterclockwise and OK. Now you can drag this slider bar, and you will see the Kelvin is rotating about the point D. Okay, based on the angle that you drag, and you even can play it. There's a play button here. You can play it, and if you move around, of course you can control the speed, how fast it. By default is 1x speed, and you click on this 1.5 to make it faster. Okay, that will make the whole class maybe more interesting. Now let us see how about the translation about vector. We have too many figures here. Let us delete some of them. You just point on the figure and you press the delete key on your keyboard, that will delete the image. And now let's learn the translation by a vector. Before translation by a vector, you need to create a vector. First, let us create a vector by pointing to this. You can see a vector here. You just need to provide 2 points for the vector. Let's say we have a vector here, the starting point and the termination point of the vector. You have created a vector. Now you go to this. You want to have the effect translate by vector onto this image. You point on the image and point on the vector, so you have a translation according to this vector. Of course this is active. You can move the vector around. You see, when the vector change, the translation about the vector change accordingly. How about if you make it a horizontal vector? So you have a horizontal translation. If you make it a vertical vector, you will have a vertical translations. Okay, you can move around, and maybe this will make the teaching of translation, rotation and reflection a bit more interesting based on how creative you are. Of course, one of the important topics in mathematics teaching is graph plotting. Let's see how to plot graph in Geogebra. If you want to plot a graph of a function, you just point your mouse to the input bar here and key in the expression for the function. For example, f equals to x squared. Of course, I'm assuming you know how to key in the x squared is head and then 2. Enter. Then you get the x squared. Of course, as usual, you can change the appearance and the color of the graph, the features of the line, and so on. Let's try another. Point your mouse to the input box here. Let's try another. G equals to sine and then exponent x. So this is how the graph look like, sine of ex. Of course, one very important notion in teaching graph plotting is the translations and the vertical and horizontal, and also the compress and extension of the graph. In particular, we want to see what is going to happen if you have a function, let's say fx equals x squared, and what is going to happen if, let's say, we change the factor a, b and c. Of course that will make the graph of the functions to be translated up down, horizontally, or even compressed or contracted. Let's see how we teach this thing or demo this thing in Geogebra. Okay, now let's consider we have a function fx equals to x squared, and we're going to create some slider bar for a, b, and c. To create that, you have a very easy way to do it. You just key in a in the input bar here and press enter. By default, it will give you a slider bar extend from -5 to 5, and we get the b and c done using the same way. Now we will key in the function g equals to f of a of x plus b, and finally the whole thing plus c. Once you press enter, you will have the function g there, and of course the behavior of g depends on the value of a, b, c. So let us adjust, tune, or slide the slider bar a, b, c. Of course, we know the c is correspond to a vertical translation up and down. When we adjust the c, we expect to have the graph moving up and down, and the factor b is correspond to a horizontal translation, and the factor a is a compress or extension of the graph horizontally. Now, of course, as a starting, we need to adjust the factor back into a node 0 effect so that we can see the effect one by one. To do this, the a should go back to 1. Of course, you may have some difficulty to adjust this. If you want, you can just point to this and just key in 1. And for the b, we should make it to 0. Now the total effect is on the c. Let's drag the c. You can see when you drag the sliding bar, the value increase and the formula also increase accordingly, change accordingly, and you can see the graph is moving up and down. Of course, maybe it's good to make this thing a bit thicker and dotted line. Now we go back to this, so we can explain easily to the student what is the effect of a in this function when we change the value, which is correspond to moving the graph of the function up and down for the base function x squared. Now we twin it back to 0, or then just key in 0 here. You have both of them overlapping. Now we look at the effect of adjusting the b. Let's see, it will be a horizontal translation. Of course, this is opposite to our intuitions. When we increase the value, the graph moves to the left. When we decrease the value, the graph moves to the right. Let's change back to 0. Get the overlapping. Now let's see the effect of a, which is compress or extend. You see, compress and extend to the factor. Of course, everything is active. If you think x squared is not a good function for you to explain, you may change the function, for example, to sine x, and you can explain also by dragging them, so you see the effect of compress and extend more obvious when you're using the sine graph, and the translations follow also, and the translation up and down also follow. Maybe this is a quick help for us to teach this concept using Geogebra. Yeah, when we teach advanced level mathematics, we will need to deal with variable functions, and therefore we need to describe 3D graphics or the function of the two variable functions where it is a surface. Let's see how we can do this in GeoGebra. For that purpose, we need a 2D graphic. So you go to the main menu, and you uncheck the graphic, but you check the 3D graphic. Then you have an input algebra menu and a 3D graphic view there. Of course, for the 3D graphic view, if this is the base XY plane, if you don't like it, you may take away the graph paper, the grid, and if you don't want this, you may also take away, make it empty, and you left behind the XYZ axis. Now we are ready to key in our two variable functions to see the surface. The first one I will try is x squared plus y squared. So you have x squared plus y squared. Of course, as expected, this is a paraboloid. And the good thing in GeoGebra is you can rotate it so that you can see it from different angle point of view. If you point it from the top, you see a circle. From the side, you see a bending. You see a bending parabola. Y equals to x squared something. And of course, you can change the appearance of the figure by changing the color, the transparency of it, and also the line. Yeah, let's have some more. We create a slide bar. Let's call it A, and let's hide this first. Maybe I need to do something else. S. So you have a S, which is a slider bar. By default, it's go from 95 to 5. Now we want to see the tracking effect. When we have x squared plus sy squared. Of course, when we later drag this s, you will see the graph change accordingly. So it's no more a circle, but it's an elliptic paraboloid. And when we turn it to negative, we'll get the shader. You see. So we drag to negative, further, we'll get the shader. Of course, you can do a little bit of zooming. You get the setup, which is a combination of bending up and bending down. If you view from here, this is a bending down. If you view from another point of side view, this is bending up. So this point is the center point, and let's hide this and have further function. How about the laminar foil? Z equals to x squared. Z equals to x squared in 3D context is a laminar foil, like this. And how about the sphere? With having an equation x squared plus y squared plus z squared equals to 1 or something. I make a mistake. X squared plus y squared plus z squared equals to 3. Let's say that. Okay, equals to 3. which is a sphere, center at the origin, the radius 3. Okay. Then we have some more. X squared plus y squared equals to z squared minus 1, let's say. You have the up and down hyperbolic of two sheets. Use the hyperbola of two sheets. Then we have some more. X squared plus y squared equals to z squared. Then we have the cone, up and down cone. Further, x squared plus y squared equals to z squared plus 1. Then we have the parabola of one sheet. It's just like a sandwich. How about plane? X plus y plus 5z equals 1. Then we have a plane. We can change the appearance of the plane by clicking on the plane. Right click and setting, go to the style. You may want to show some light line, and you may want the opacity to be thicker. Then you rotate it about to see the intersections between them is an ellipse, so cut by the plane. Of course, you can try on many more of these shapes by referring to the advanced calculus book. There are many other interesting shapes, and you can try to plot it using Geogebra and rotate it and view the situations. It will be quite interesting to experiment on. Okay, now we learn how to do some standard 3D drawing, standard shape pyramid. Okay, let's first get these two views together side by side. In order to do that, we go to the menu here, go to view, and check the graphic and the 3D graphic together. So you have two view, in fact algebra view also, three view together. Now we start by making the base of the box. You do it easier in 2D graphic view on the XY plane. So you go to this, just simply make a polygon, which is a rectangle. After that, you see the 3D view, there is a rectangle on the base. Now you point the mouse to the 3D graphical view, and you point to this pyramid shape, and you select the prism. Then you select the base, and you need a top point. So this will form you a box. And the good thing is, of course, you can put this a bit side because you don't need that, and you can rotate it to different point of view in 3D graphic. And let's try the net. Okay, you select the polygon and it will give you the net. This is how the thing is formed by folding a piece of paper. You can drag this bar, see how this is formed. Of course, it's very good to explain to students on geometry. Of course, you even can play it, and it will run automatically, or you can control the speed of how far it's playing, and it will just play on and off like that. Okay, let's stop it, and we have another shape. Now let's try to draw a pyramid in the 2D graphical view. You need another polygon which define the base of the pyramid. Then in the 3D graphical view, you select the pyramid and select the pyramid again. Click on the base and give it a top point. Then you have the pyramid already with you, and you can rotate to have different point of view. Let's try the net again. Select the net and select the shape that you're targeting. Then you can drag the bar to see how the net fall. Okay, quite a nice thing to have, right? Now we try to calculate the diagonal angle of a box. First, we draw a box, need a polygon. Let's draw a polygon here. And you see a polygon on the base XY in 3D. And now we select this prism, get the base and move it up there to get a box, and rotate a bit to see it. Now let's target the diagonal. We need to mark it by getting a segment connecting C to another vertex here, which is H. This is the diagonal line, and we want to find the angle between the diagonal line to the base. Of course, to better visualize, it's good to have another line segment connecting C to A also draw. With that, you can rotate a bit to show the student the meaning of the diagonal angle. Now let us use GeoGebra to find this angle. You click on this angle, select the angle, and just click on the 3 points that form a triangle H, C, and A. After finish, you should see the angle is already calculated automatically. GeoGebra can move around. Now you can rotate your box. Hopefully this will give more interesting explanations in your class with the help of GeoGebra, instead of drawing it on your whiteboard or blackboard. This for sure will be much more interesting when you're teaching this subject. Yeah, in GeoGebra we also can do a little bit of statistic stuff. For example, distribution. In order to get this view, you go to menu, and on the view you deselect everything except you click on this probability calculator. Then you lead you to this view. There are quite a number of distributions that you can select. The continuous one, for example, the normal, student, t, chi-square, and so on. And for the discrete one, you have binomial, Pascal, Poisson, and hypergeometry. Let's take a quick look on this. We are in the normal distribution. Of course, you can change the mean instead of standard mu 0 and sigma 1. You can change to anything you like. Let's say mean equals to 50 and the sigma equals to let's say 12. And under these conditions, you want to find the probability x in between 28 to 62, or maybe it's anything you key in 78. Then the probability is calculated for you, and even the sections below the curve, the bell shape, is also highlighted for you. You may also try the one side probability. For example, you want to know what is the probability x is larger than 38, or even another side x is lesser than, let's say, 45. Of course, there are much more things you can do in statistics, but we just touch up to this level. Yeah, after we have talked a little bit on statistics, now we talk a little bit on the metrics in GeoGebra. So now I'm totally on the algebra view. I don't want the other view because I'm doing a metric calculation. And to key in the metrics, you start by using the curly bracket. Curly bracket for the first row, let's say 2, 3. Another curly bracket for the second row, let's say 5, 6. Then enter. You get the matrix A, which is 2 by 2. Now let's try to get another matrix B, type B equals 2. Using the curly bracket, we want to make it 2 row 1 column. Let's say 7, and then 8. So you get a 2 by 1 matrix. How about we multiply A to B? A times just a normal star multiply B like that. It will give you the result A times B. Of course, in matrix, you should know some of the standard operation like transpose, inverse, and also the determinant. Let's do it one by one. We try to find the inverse of the matrix M. Command invert. Okay, this is the inverse of the matrix A. Let's try to find the transpose. The command is transpose. Okay, this is a transpose of A. I hope you can see it, the transpose of A. Now continue on to find another, which is the determinant. Command determinant. Of course, you can select it, and now you can key in the matrix, which is our A. So the determinant is -3. Of course, many other things you can explore in matrix and also vector in Geogebra. Okay, let's see how calculus and algebra can be done in Geogebra. We are in the normal 2D graphical view and algebra view. Let's try to do some deposition. We first define the function f equals to sine x, sine 3x. The graph is also given actually. If you want to calculate the deposition, you just press F prime and you get the graph and also the derivative. If you don't want the graph, you can just hide it. Now F prime prime, F prime prime prime, and so on and so on. How about the integration? The command is integral. Integral of what? Of the function f. Of course, the graph also given, and the c is automatically generated. Is actually stand for the constant of integrations plus c, and c1 here, this don't bother. So this is a -1/3 cos 3x for the integration. Now let's look at the definite integral. We want to integrate the function, let's say from 1 to something. Oh. Let's say 1 to 3, and you can see the area below the curve is highlighted there, and the integral is given by 0.0263 up to 4 decimal places. Now if you want to make this dynamic, you may change the upper limit 3 to C1 and make use of the dragging bar to drag it. C1. Now you can do a dragging, and you can see when you drag along, the integral will just calculate for you accordingly, and the highlight area also do it for you. Of course, you can change the color of the thing to make it nicer. And so on. Okay, that will be very good during teaching. You want to demo this to the student. And besides this standard calculus, we can do some algebra on the function. For example, expand, factorize, and finding the root. Let's try to expand a function. Here we use the command expand, bracket, inside there is a polynomial. We make it power 3. Power 3. Almost straight away give you the expansion. In fact, the graph also is given to you. Expand 1 minus 2x power 3. Of course, we can do it the other way around, which is factor. Let us define a polynomial k equals to x squared plus x minus 2, and we can factorize this using the command factor. can see factor into two brackets because these are quadratic. And of course, you can solve k. That means to find the root of the function k. Let us hide some of them that we don't want. Also hide the sine function. Just leave behind the k and make it a bit smaller zoom. And now we try to find the root of the function. Now we try to find the root of the function. Our function is k. After factorize x minus 1 x plus, of course we expect the root will be 1 and negative 2. Now let's verify this. Root k. K is the function. And you can see negative 2 and 1 to be the root. And of course the value of the function at these 2 points are both 0. And in fact the root are plotted here, a and b, which is just the intersection between the curve and the x-axis, or where the graph of the function cross the x-axis. Yeah, one thing I forgot to mention, there is one feature to key in some of the special symbol or function or operator. There is a virtual keyboard here. As you can see here, virtual keyboard. Click on this, and you have plenty of choice there. Numbers, operator, standard function, virtual keyboard, capital letter, small letter, and this is important thing, the Greek alphabet, small letter, that's capital letter, and some other extra operators. Okay, sometimes it's useful. And the list of all the functions, built-in function in Geogebra is here. Geometry function, logic function, function relevant to matrix and vector, and so on. You can explore it here. Okay, one more last thing I'd like to share with you before I end this video, which I think is quite interesting, because especially for those who are teaching calculus of upper secondary level, you need this to explain the surface and the volume of revolution. Let's see how. First, I need to create maybe a function. Let's do it using the freehand in the 2D graphic. Freehand object. Yep, you just simply draw something, and then you have it here on the XY plane. Now we come to the 3D graphical view. Go and select this one. Yes, this one, the pyramid side. There is a surface of revolution, but before that, let us rotate to a suitable angle so that later we can rotate easier. Now I will select this surface of revolution. You need to select the object that you have drawn just now, which is just a freehand curve. Now you just run it along this axis. Click on it, and then you don't let go your mouse, and you drag it along the axis of revolution. Then the Geogebra will give you a very nice looking surface of revolutions. Can you imagine how nice this will be during the class if you have this thing with you to explain the surface revolution to the student in the real time? I don't want to close the loop, make a gap here, and now you go back to this and you can do a rotation to explain to the student, and later explain further, use calculus to find the volume and also the surface area of this thing. Okay, you find this interesting? Of course, we should not forget those big variety of resources available free online in the Geogebra website. If you go to geogebra.org, click on the resource, then you have this in the search bar. You can search anything you like. For example, if I'm interested on statistics, I can click statistics and enter. just like Google search, there are many GeoGebra projects done by other teacher or lecturer or other people all over the world being put online, and you can click on it and get the idea of other people, and if you like it, you can modify or maybe use it during your class teaching. There's a huge data there, resources there for you to make use of and learn from. Okay, I think with this I almost end my talk. Yep, of course there are many more useful features and menu of GeoGebra are yet to be explored, and it's quite interesting to note that GeoGebra also support webcam. You go to ABC and go to image. Beside choosing a file to import, you may select the webcam. If your webcam is ready, then you have it for you. Okay, I hope you enjoyed this video. That's all from me. Bye. See you around.